Hi there and welcome to another video for the AQA Linear GCSE Higher paper. This is the practice paper set 2 and it's the non-calculator paper for an hour and 30 minutes. Let's work our way through this. Okay, first question. We have a distance time graph and we're told that Mary walks from her home to a cafe and back. So we should probably highlight that. She's going to a cafe and back. The distance time graph shows her walk. This is the distance from her home. This point here, it represents the cafe. This is the time. Home is at 0. So before we answer any questions, let's just think about what's happening here. Mary, between time 0 and 1 hour, okay, in an hour she walks 4 kilometers from her home, and the graph is a straight line here, so that means that she's walking at a steady speed. Then between 1 o'clock and 1:30 she stops and she takes a break because her distance is not changing over that time. Then at 1:30 she starts again and she walks at she walks to the cafe, which is a further 2 kilometers away, and it takes her half an hour, and in that time she at 2 o'clock she stops. She stops for an hour at the cafe, and then in one go, in 1 hour and a half, she walks directly back to her house, again in this constant speed. Just thinking where's what the speed is at each point. In half an hour she goes 2 kilometers, so in 1 hour she goes 4 kilometers. So for this bit she's walking 4 kilometers per hour. Here, half an hour, 2 kilometers. So again, as you go across one, you go up 2. Here, this must be 4 kilometers per hour here. And then here, she's doing the exact same. On the way back, she's going in 1 hour, she's going 4 kilometers. So again, she's going 4 kilometers per hour. Okay, so I've analysed that. Let's answer all the questions now. How far does Mary walk altogether? Well, here, 4 kilometers, and 2 is 6, and 6 back, so it's 12 kilometers. So easily 12 kilometers. Mary sets off at 9 AM. What time does she arrive at the cafe? Here's 9 AM. She arrives at the cafe 2 hours later, so that's at 11 AM. 11 AM. Nice, easy question. Work out her average speed on the way back from the cafe. Well, we've already done that, but remember, speed is distance divided by time. What distance does she go? Well, she goes 6 kilometers in an hour and a half. So 6 divided by 1.5, and you would get 4 kilometers per hour. So the answer is 4 there. Easy, easy, easy. 4 marks to start the paper off with. Complete the table showing the properties of some quadrilateral. Tick or cross the columns. The first one has been done for you. So we are given a parallelogram. Both pairs of opposite angles are equal. Okay, both pairs, so that angle and that angle and that angle and that angle are equal. That's true. All sides are equal. Well, in a parallelogram generally they're not. Diagonals cross at right angles. Well, here that doesn't look like the case, so then we crossed it. Okay, both pairs of opposite angles are equal. Is that angle equal to that angle? Well, no. Are all sides equal? That side and that side are not equal, and that side are certainly not equal, so no. Do the diagonals cross at the right angles? No, I mean, there's no reason why they should. That works in a square, but there shouldn't be any reason why that works in a trapezium, so no. Okay, both pairs of opposite angles are equal in a kite. Is it true that is that angle equal to that angle? Well, yes, it is. But is that angle equal to that angle? No, it isn't. Because we need both pairs equal. All sides are equal. Are all sides equal? Well, these two are equal, but these two are not the same as these two, so no. And diagonals cross at right angles. Well, let's check that one out. You should know this one here. That crosses with that. That is indeed at a right angle, so yes. Again, easy 3 marks. Draw or name this quadrilateral. Both pairs of opposite angles are equal. All sides are equal. Diagonals cross at a right angle. Well, square is the easiest one there. Okay, if we just think about it, a square, of course all sides are the same. That's the definition of a square, so we've got that one. The diagonals cross at right angles. Yes, they do. And opposite angles are the same. Yes, they are all 90, so that is indeed true. It is also true that a rhombus would work for this one, but stick to the easy marks. Stick to the easy suggestions. Okay, next question, question 3. The star here just indicates you've got to be careful writing out your work and showing each step, because there are marks for working. A raffle has 3 prizes. First prize, £40. Second prize, 3/4 of the first prize. Third prize is half of the second prize. Raffle tickets are 50p each. How many raffle tickets need to be sold to make a profit of 70? First of all, let's work out the total prize money. So, first prize is £40, we know that. Second prize is 3/4 of this, so it's 3/4 of 40, which you should be able to spot easily is £30. And the third prize is half of the second prize. So it's half of 30, which is £15. So the total prize money is the sum of these, which is equal to £85. Okay, so that's how much money you give out. Okay, now to make a profit of 70, remember, I'm just going to go over here. Profit is your sales minus your costs. Now, the only costs you've got are this £85 worth of prize money. So therefore, to work out your sales must be the profit you want plus your costs. Okay, and the profit you want is 70, your costs are 85, so therefore you need sales of the sum of these two, which is equal to £155. That's how much sales you need. You should work down the page here, I'm just running out of space. Now, raffle tickets are 50p each. How many do you have to sell? So number of raffle tickets must be your profit, it must be the sales you need, 155 over 50p, which is £0.5, divided by half is the same as timesing by 2, so this is £310. So that is, 310, not pounds there, 310 raffle tickets. Okay, and you're done there. How many tickets need to be sold? 310 is your answer, underline it. Question 4. The average speed of a car is 50 miles per hour. The journey is 400 kilometers. How long will the journey last? State any conversions you use. Now, this is one thing you have to learn these conversions. You have to learn that 5 miles is the same as 8 kilometers. Okay, that's something you need to learn. Now, one way I learn it, I tend to actually use the Fibonacci sequence. Fibonacci sequence, you add the 2 previous numbers, so 1, 1, 2, add these 3, add these 5, add these 8, add these 13, add these 21. The way I always remember it is I just think here, 5 miles, if that's 5 miles, then the next number is 8, so that's 8 kilometers. Obviously, you know, miles, there are more kilometers in a mile than 1, so therefore you know that it goes this way around. That's how I personally remember it. Okay. Also, you need to know that speed is equal to distance over time. From science, you would have learned speed, distance, time formula like that. Now, just making sure all the units are the same. Here we're dealing with miles per hour. Here we're dealing with kilometers. So we just got to make sure all the units are the same. How long will the journey last? Well, we want time. So time is therefore distance over speed. So time is equal to distance over speed. Right. So I suppose it would be easier to convert 50 miles an hour into kilometers an hour, wouldn't it? That would be equal to 50 miles per hour divided by 400. Sorry, I've done this the wrong way around. Sorry. The distance is 400 kilometers divided by 50 miles per hour. Now, you can't just divide these straight away, they've got to be the same units. So it might be easier to convert 50 miles an hour to kilometres, because you know 5 miles is 8 kilometres, so 50 miles is 80 kilometres. So 50 miles per hour must be 80 kilometres per hour. So this is 400 kilometres divided by 80 kilometres per hour. Okay, and now you can divide these. 400 divided by 80, well, that's the same as 40 divided by 8, which is 5. So the distance, the time must be 5, and what's our unit? We're all dealing with hours, so it must be 5 hours. State your answer and underline it, and you're done. Nice, easy question there. Couple of things to remember. Speed is distance over time formula. When using that, the units have to be consistent. If your distance is in kilometres and your let's say your speed is in miles per hour, you have to convert so they're all in miles or kilometres, whichever's easiest. And 5 miles is 8 kilometres. I remember that using Fibonacci. Okay, the mode of 5 numbers is 3. The median is 7. The mean is 6. Work out the 5 numbers. Now, the mode of 5 numbers, if you've got 5 numbers, let's just write boxes for each of the 5. 1, 2, 3, 4, 5. Okay, let's just point out various places. The median is going to be there. It's the middle number when you put them in order, because your 5 numbers, you can put them in rank order. So the median is going to be this middle one, the third one, and that's going to be 7. You're told that, right? Now, the mode of the 5 numbers is 3. And the mean is 6. So the mode of the 5 numbers is 3. Now, how could that be the case? Let's just think how that could be the case. If we had 1, 3, let's say here, that would not be enough to be the mode, because 7 could be the mode as well, or other numbers could be the mode. Okay, so we at least have to have 2 3s, because then these 2 3s are equal, there are more of them than there are this 7. Now this only then works if these 2 numbers are different. Okay, these 2 numbers have to be different, because if these were both 7, then 7 would be the mode. If they were both 8, 3 and 8 would be the mode. So they have to be different. So let's just see what they could be. If we want the mean to be 6, if we want the mean to be 6, and we've got 5 numbers, then they must add up to 30. So the 5 numbers must add to 30. Okay, so these 3 currently add up to 13. If you want to add them to 30, you need these 2 to add up to 17, and therefore we could easily pick 8 and 9, and they would be our numbers. So 3, 3, 7, 8 and 9 do the trick for us. The median is 7, the mode is 3 because there are 2 3s, and they add up to 30, and 30 divided by 5 gives me a mean of 6. Question 6. Work out the area of a trapezium. This is given in the formula booklet. This formula is absolutely easy. It's a half the parallel sides added up times the perpendicular distance that they are apart. Remember, it's that distance, not, let's say, that distance if they gave it to you. It's the perpendicular distance the parallel sides are apart. So it's just a substitution game. A half, 5 plus 9 multiplied by 4, which is a half. 5 plus 9 is 14 multiplied by 4. Do the half times 14 first. That's 7 multiplied by 4, which is 28 centimetres squared. Underline your work. Absolutely easy. Question 7. The costs and distances for 10 coach journeys are shown on the scatter diagram. Draw the line of best fit. The line of best fit must go through as many as possible and try and have equal numbers on each side. It can't start before the first point, like it can't start there and end past the last point. It's got to start in line with the first point. Okay, so let's have a go at doing that. Let's start somewhere like here, and we can change this as we go along. That there, is that a good line of best fit? Well, maybe not, because there are 1, 2, 3, 4, 5 above the line. So let's just move this That might be a little better. Let's just adjust that there. Let's see. We've got 1, 2, 3, 4, 5 on the line, 2 below and 1 above. That's pretty good, or maybe even that's just absolutely spot on. You've got 1, 2, 3, 4 on the line, 3 below, 3 above. That's looking pretty good as a line of best fit. So that would be my line of best fit there. Estimate the cost of a journey of 175 miles. Now, you must use your diagram to do this. If you don't draw a line on your diagram for this, you will get no marks. So 175 miles, go across here. 175 miles must be here because 50 miles is one massive square, so a little square must be 25. So 175 miles must be about there. You read across, and I'm getting 26, 27, 28, 20. I'm getting about £29 there. I'm getting about 29. Let's just double check that. About 29 or 30, something like that. 29 or 30 pounds. So let's put 29 pounds there. The scatter diagram shows positive correlation. Explain what this means for the relationship between the cost and the distance. They just want you to explain what positive correlation means here. Now, obviously, it means that the further you travel, the longer the distance of a coach journey, the more expensive that the cost of that journey is. So it's simple as this. It is the longer the coach journey, the more expensive it is. The more expensive it is. Simple. Absolutely simple there. Question 8. An arrowhead is drawn inside a square of size 6. This is a square. It's important you read the question carefully. So obviously this distance is also 6 centimetres. X is the midpoint of one side. So this distance here, clearly, must be 3 centimetres, as is this distance, which is 3 centimetres. Y is the centre of the square. So if that's the centre of the square, then the distance, the height of this must also be 3 centimetres. Okay? Work out the area of the arrowhead. Well, for my mind, the area of the arrowhead, so I would actually just do this in pictures, the area of the arrowhead here is equal to the area of the square, okay, subtract. Now this triangle and this triangle are the same, so I would say subtract 2 of these triangles, this one and this one, and I would also need to subtract that triangle here, so that triangle. And that's how I would explain what I'm doing there. So this would be equal to 6 multiplied by 6, it's a square. This would be subtract 2. Now what's the area of this triangle? Half the base times the height, so it'd be a half, let's say a half times 6 times 3, so it'd be a half times 6 times 3, okay? And then this triangle here is a half times 6 times 3 as well, because it's half the base times the height, so minus a half times 6 times 3. Okay, so 6 times 6 is 36. A half times 6 times 3 is 9, and 2 times 9 is 18, so that would be subtract 18. And this one here, half times 6 times 3, half times 6 is 3, and 3 times 3 is 9, so that would be subtract 9. And if you do 36, take away 18, take away 9, you get 9 centimetres squared, and it's as simple as that. Okay, so it's nice, I would always do it as follows. It's nice with a picture to explain exactly what you're doing. Maybe even call this triangle 1. So when you're labeling it, it's obvious what you're doing, and call that triangle 2. Okay, and that's very obvious what you're doing then. Easy 3 marks. Question 9. Work out the highest common factor of 30 and 18. Okay, now what is a highest common factor means what is the largest number that divides both into 30 and 18? Now, if you think about it, you could do it by listing out the factors of 30 and listing out the factors of 80. 30 would be 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 and 6, and then you're done. And if you want to list out the common factors of 80, well, it's 1 and 80, 2 and 40. Does 3 go in? 3 doesn't go into it. Does 4 go in? 4 and 20. Does 5 go in? Well, 5 goes in, yeah, 16 times. So 5 and 16. Does 6 go in? No. 7? No. 8? Well, it would be 8 and 10. 9? No. And then you're done. So the highest common factor, what factor's in both of them? Well, a 10 is the largest, so it'd be 10. It's easy to spot that as well, but that's just an example of how you might do it. And the least common multiple of 30 and 80, we'll just list out the multiples: 30, 60, 90, 120, 150, 180, 210, let's say 240. Let's just stop there for now. And the next one for 80, list out the multiples: 80, 160, 240. And you can clearly see 240 is the smallest number in both multiple lists. Okay, now just as an aside, it's not needed for a simple question like this. I just want to show you how to do it in a more complicated case. Maybe the numbers are larger and you want to use prime factor decomposition. So 30 and 80, first you would write 30 and 80 as a list of their, as a product of their prime factors. So the prime numbers are 2, 3, 5, 7, 11, 13, etc. So you ask yourself, does 2 go into it? Yes, circle it 15 times. Does 2 go into it? Yes, 15 times. Is 15 prime? No. Does 2 go into it? No. Does 3? Yes, circle it, and it goes in 5 times, and 5 is prime. So 30 is therefore 2 times 3 times 5. Okay, and do the same with 80. Does 2 go into it? Yes, circle it 40 times. Does 2 go into it? Yes, circle it 20 times. Does 2 go into it? Yes, circle it 10 times. Does 2 go into it? Yes, circle it 5 times, and 5 is prime. So 80 is 2 times 2 times 2 times 2 times 5. Right, that would be the first step. Now, I'm just showing you this because they might be different numbers. And then what you do is you draw a Venn diagram for each one. You draw a Venn diagram here, and what you do with this Venn diagram is the first circle represents 30, and and the next one represents 80. Now anything that's in both lists goes in the centre. There's a 2 in both, so 2 goes in the centre, and there's a 5 in both, so 5 goes in the centre. And then anything that's left over with the 30 goes in the 30, so that 3, and then anything left over here, 2 times 2 times 2, 2 times 2 times 2, goes left over here. Now the highest common factor is always the middle one, so the highest common factor is the product of these, the multiple, which is 2 times 5, which is 10, that agrees with us up there. And the least common multiple is the product of all these numbers. Now you know 2 times 5 is 10, 2 times 2 times 2 is 8, and 3 is left over here. And 3 times 10 times 8 is 30 times 8, which is 240. It gets you it that way as well. Whichever way you find easiest, in this simple case for 3 marks, I would just list them out. But if the numbers were harder, do remember you can use prime factor decomposition and Venn diagrams. Next question. Ellie has 3,000 songs on her MP3 player. On Monday, she listened to 50 songs chosen at random. 15 were rock songs. Estimate the total number of rock songs on her MP3 player. So she listened to 50 at random, and 15 were rock songs. So 15 out of 50 is an approximation to the ratio of rock songs she has in her MP3 player. So if you multiply this by 3,000, that will tell you a rough estimate of how many she has on her whole MP3 player of rock songs. Now, how would I do this calculation? Well, what I would firstly do is I would simplify this fraction. I would divide top and bottom by 5, so it would be 3 out of 10 multiplied by 3,000, which is 0.3 times 3,000. Okay, which is the same if you want to multiply that by 10, 3, and then you would divide that by 10, the same as 3 times 300, which is actually 900. And then sense check it. Does that sound reasonable? Yeah, it sounds pretty reasonable. That's one way of doing it. Another way, just out of interest, what you might do is you might say 15 out of 50 songs were rock songs, and you might say, oh, well, I want to use this fraction and convert it into a fraction with 3,000 on the bottom. How many out of 3,000 would have been rock songs? So you can use equivalent fractions here. What do you need to do to 50 to get 3,000? Well, you need to multiply it by 60. So you do the same to the top, and 15 times 60, well, 10 times 60 is 600, 5 times 60 is 300, it would be 900. So 900 out of 3,000 would have been rock songs. Again, the same way we did it previously, the same answer we got previously. Question 10b. On Tuesday, she again listened to 50 songs chosen at random. 10 were rock songs. Give a reason why the number of rock songs was different each day. There is one word here that gets you the mark, and the word here is random. This is the word you must get into this answer, because that will get you the mark. And the way you say it is you just say the selection was chosen at random. And that's enough. Because it's random, you will get different outcomes each time you do the experiment. That is the definition, or that is one of the implications of being random. So that is the most important word you have to get in there. Question 11. Make x the subject of the formula. You want x equals something with y's, numbers, and subtractions and additions in it. First things first, take away 3 off both sides. So y subtract 3 would be 2x. Then divide both sides by 2. Y subtract 3 over 2 is equal to x. Then probably write it with the x on the left-hand side. X is y subtract 3 over 2. Simple as that. Easy 2 marks. Question 12. Write down the value of 2 to the power of 0. You should know any number to the power of 0 is 1. You must know that. 2 to the minus 1. Some number, anything to the minus power, and that minus means 1 over that thing to the positive power. So 2 to the minus 1 in particular means 1 over 2 to the 1, which is 1 over 2, which is a half. So this is simply a half. Work out the value of 2 to the minus 1 plus 2 to the minus 2. Give your answer as a fraction. 2 to the minus 1, we've just said, is a half. 2 to the minus 2 means 1 over 2 squared, which is 1 over 4. Okay, so this is equal to a half plus a quarter. You can't add, well, you should be able to do this straight away, but you can't add fractions until the bottom number is the same. Convert that to 4. You'd have to times top and bottom by 2. So it's 2 quarters plus 1 quarter, which is simply 3 quarters. And that is your answer, 3 quarters. Very easy. Question 13. Draw the region defined by the inequalities. Mark your region clearly with an R. This is 3 marks. First things first, forget about the inequalities. Draw the line x equal 1. What is the line where the x coordinate is always 1? You really should be able to do this. That is the line x equal 1. Then draw the line y equal x. You should know that line. It's a diagonal line where all the x and y coordinates are the same. 2, 2, 3, 3, 4, 4, etc. So that is the line y equal x. And then you want to draw the line x plus y equals 6. Different ways of doing this. Probably the easiest way I would suggest is say when x is 0, what would y be? If x is 0, y is 6. So when x is 0 across, y is 6. And if y is 0, x must be 6. Okay? So it would look like that there. Okay? Now, another way of doing it is just to rearrange it in the form y is equal to 6 minus x. Therefore, you know the y-intercept is 6, and you know it's got a negative gradient of 1, so it goes down like that. I think this is the easiest. Sub in x is 0, get y. Sub in y is 0, get x. Draw a line between the 2 points. Now let's think what we want here. We want x to be bigger than 1, so we want this side of the line. Anything this side of the line is x bigger than 1, right? So just do that to mark it out for yourself. We want y to be bigger than x, so for example, if this is y equal x, here the y number's 5, the x number's 4, anything this side is y bigger than or equal to x, so we want that there. And x plus y is less than 6, here x plus y equals 6, so less than 6 must be below the line, i.e. here. Where do all the inequalities hold at the same time? They hold inside this triangle here. And that is your region for your 3 marks. Question 14. Solve that equation there. First thing I would do, I've got a 2 on the bottom, I would multiply everything by 2. And I would get x subtract 1. If I do it step by step, 2 plus 2, x plus 3. Remember to keep these in brackets, over 3 is equal to 2. Now those 2's cancel, and I would just get x subtract 1 plus 2x plus 3 over 3 is equal to 2. Now I've got 3 on the bottom, let's multiply everything by 3. So that would be 3x subtract 1 plus 3 times 2x plus 3 over 3 is equal to 6. Because there's a 3 times on top and on bottom, they cancel. So I would simply get 3x subtract 1 plus 2x plus 3 is equal to 6. Expand your brackets, 3x subtract 3 plus 2x plus 6 is equal to 6. Then what we do is combine x's. 3x plus 2x is 5x. Negative 3 plus 6 is plus 3 is equal to 6. Subtract 3 off both sides, 5x would be equal to 3. Divide by 3, x is 3 over 5, which is equal to 0.6. Okay, and that's your answer. Then I would encourage you to check it. Is it easy to check? Well, it's not too bad. 0.6 take away 1 is negative 0.4. Negative 0.4 over 2 is negative 0.2. And then 0.6 plus 3 is 3.6. 3.6 divided by 3 is 1.2. If you add those together, you do get 1, which is what you're looking for. Now, I just want to take a moment to show you potentially a quicker way of doing this. If you have 2 fractions on the bottom here, you could multiply everything by their lowest common multiple. The lowest common multiple of 2 and 3 is 6, the smallest number that they both go into. Multiply everything by 6 in one go. That would be 6x minus 1 over 2 plus 6x plus 3 over 3 is equal to 6. 6 over 2 is 3. 6 over 3 is 2. And you get the answer in an easy move. If you keep going there with your algebra, you'll get the same thing, but in a lot less moves than we did previously. It's up to you what you're more comfortable with. Question 15. A sequence of shapes is made from centimetre squares. Work out an expression for the perimeter here, not the area. Do read the question of shape n. The perimeter here is 4, right? So let's draw out a little table for ourselves here. So the term, first term, and the perimeter is 4. The perimeter here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10. The perimeter here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. Okay, now do mark them off as I've done. Don't make a silly mistake there, and that will cost you easy marks here. Now, what are these going up in? They're going up in 6s. Okay, so what's this like? It's like the 6 times tables. The 6 times tables are 6, 12, 18, etc. The nth one would be 6n. They're not quite the 6 times tables, they're 2 less, so therefore the nth term of this would be 6n subtract 2. Simple as that. Question 16. Simplify fully the following. If you are asked, write this down if in case you don't remember. If you are asked to simplify algebraic fractions, step 1, factorise everything you see. Factorise top plus bottom. You must do this. If you don't, you have no hope. Step 2, cancel where appropriate. Cancel factors. Cancel things that are timesing on the top and the bottom that are equal. So cancel factors of top and bottom. And that will get you the answer you're looking for. One little tip in the factorised section in particular, look out for difference of 2 squares. They come up a lot in these questions. Okay, let's have a go at this one. X squared subtract 36. You should know that x squared subtract a squared factorises to x plus a, x minus a. So x squared subtract 36, which is x squared subtract 6 squared, must factorise to x plus 6, x subtract 6. So that is one to always look out for. When you factorise this, you get x plus 6, x subtract 6, all divided by. Now, what divides into 3x and 18? Well, 3 does. And then you're left with, in brackets, x plus 6. Oh, look, something cancels. X plus 6 is multiplying on top, x plus 6 is multiplying on bottom, so therefore you're left with x subtract 6 divided by 3. Leave your answer like that. Do not go any further and try and divide that. That's absolutely fine as it is. If you go forward and try and cancel that or do whatever and make a mistake, you'll get none of the marks. Question 17. PQR is a straight line. Use the information to find the values of x and y. Oh, and ABCD is a parallelogram. Now, this is 5 marks, but these are 5 absolutely give me marks if you've got your wits about you. Because that's a straight line, these angles must add to 180. So y plus x plus 60 must add to 180. Okay, before we go ahead and deal with the algebra on this, let's just get all the numbers to one side. Let's subtract 60 from both sides and maybe even make the x first. Well, if I subtract 60, I get y plus x is equal to 120. And if I swap the roles of x and y, x plus y is equal to 120. There's equation 1. Okay? Now I'm going to go for a different coloured pen here. If this is a parallelogram, that and that are parallel. Therefore, C angles are in operation and all interior angles add to 180. These two must add to 180. Let's write it down. 2x subtract 40 plus y plus 50 must add up to 180. Let's tidy up just like we did above. Negative 40 plus 50 is plus 10, so 2x plus y plus 10 is 180. Let's get all the numbers to one side, subtract 10 off both sides. 2x plus y is equal to 170, equation 2. Now, we are in a perfect position here to find x and y. We've got 2 simultaneous equations, this one here, and this one here. Okay, so what if I did equation 2, I'll go for a blue pen here, equation 2, take away equation 1. We've got the same number of y's, so if we do this, we will eliminate the y's. 2x take away 1x is 1x, y take away y is nothing, 170 take away 120 is 50. Oh my, we've got y is 50 degrees, one of our answers. To get the y, stick it back in one of the equations, stick it back here. 50 plus y is 120, y therefore must be 70 degrees. And they look really hard, this question here, but actually for the 5 marks, if you just know your angle facts and are good at simultaneous equations, it's probably the easiest marks on the paper. Okay, question 18. A cone and a hemisphere being half a sphere, are joined to make a toy as shown. They both have radius of radius r, the total height is 4r. So let's just label in, that must be r, clearly. And clearly, if this is a hemisphere, that must be r as well. Agreed? Now, if that's r, the remaining distance here must be 3r. Because if the whole lot's 4r, and this bit here is r, this bit here must be 3r. Okay? So that's the key to this question, I think, labelling out your picture. The manufacturer works out a formula for the volume of the toy. Work out this formula, give your answer in terms of pi. Now, the volume of the toy, let's get ourselves some easy marks. The volume of the toy is the volume of the cone plus the volume of the hemisphere, right? Simple as that. Now, you are given the formulas of a cone and a sphere in your formula booklet, okay? Now, if you look in your formula booklet, it gives you the volume of a sphere as 4/3 pi r cubed. So half of that, the volume of a hemisphere, must be 2/3 pi r cubed, right? So therefore, subbing this in, it must be 2/3 pi r cubed, right? Now, what about the volume of a cone? You are given in your formula booklet that the volume of a cone is 1/3 pi r squared times h, where h is the height of the cone. Now, in this case, we have a cone radius r, but we've got a height of 3r. So therefore, subbing this in, it would be 1/3 pi r squared times h, where h is 3r. Okay, so let's then keep going with this. 1/3 pi r squared times 3r. Well, 1/3 times the 3 is 1, and therefore you get pi r squared times r, which is pi r cubed. Okay, pi r cubed plus 2/3 pi r cubed. Now, how to think of this? The easiest way to think of it is I've got 1 pi r cubed and I add 2/3 pi r cubed. So I've got 1 plus 2/3, which is 5/3 pi r cubed, or 1 2/3 pi r cubed. Okay, so this is equal, therefore, if you add 1 pi r cubed plus 2/3 pi r cubed must be 1 2/3 pi r cubed, which is 5/3 pi r cubed. That's the formula you're looking for, and that is the volume that you were asked to find. Okay, and there, for 4 marks, you've got the volume of the formula in terms of pi, the volume of the toy in terms of pi. And question 19, lastly, choose 2 numbers, for example 8 and 5, we're told. Subtract the smaller number from the larger number, square the result. Square the numbers and add. Work out the difference of the 2 results. The result is 2 times the product of the original numbers. Prove this result algebraically. So we're going to choose 2 numbers, let's say x and y. So we're going to choose 2 numbers. Let's do it step by step, exactly what they do. Let's choose x and y. Let's assume x is bigger than y. It doesn't matter, we could make y bigger than x, whatever. Let's just pick x to be the bigger number. Subtract the smaller from the larger and square the result. Do x, take away y, and square it. Now, what do you get when you do that? This means x subtract y, which you should know how to expand. It would be x squared, subtract xy, subtract yx, which is the same thing as subtract xy, plus y squared. Be careful, a minus times a minus. So this is x squared, subtract 2xy plus y squared. And that is our x minus y squared, and we've done up to this line here. Then square the numbers and add them. So the first thing, you square the numbers and add them. If you did that for this line here, let's go for a different coloured pen. For this one here, you would square the numbers, x squared, y squared, and you would add them. It is not saying to do x plus y squared. That would be to add them and square them. It's saying to square them, then add them. Okay? Okay, so now we've done that step. And then it says work out the difference of the 2 results here. We're going to take the 2 results away from each other. So we're going to take the red one and we're going to subtract the blue one, okay, using this algorithm here. So we're going to take the red one, we're going to have x squared plus y squared. and we're going to subtract x squared, subtract 2xy plus y squared. X squared take away x squared is nothing. Y squared take away y squared is nothing. And 0 take away negative 2xy is positive 2xy. And that, you get 2xy, and that is exactly what you wanted, 2 times the product of the original numbers. 2 times product of original numbers. Okay, and then you're done. Okay, question 20. A bag contains X apples, 2 X oranges and 1 banana. 2 items of fruit are selected at random of the bag without replacement. The probability of selecting an apple followed by an orange is 5/23. How many apples are in the bag? Okay, this is going to distinguish candidates here significantly. All you need to do is firstly get some easy marks and state firstly how much fruit is in the bag. Fruit in bag must be x plus 2x plus 1, which is 3x plus 1. Right? Simple as that. Okay, next thing. So you want to select an apple followed by an orange. Let's just do a quick tree diagram here. Apple, and then you have not apple, and then afterwards you want an orange. So you want an orange or a not orange. There's not orange here. Okay, so what's the probability of getting an apple? There are probability of apple, first one, or there are X apples out of 3x plus 1 items of fruit. Okay, so it's x over 3x plus 1. Now, you've just taken an apple out, so you've taken 1 item of fruit out. So there were 3x plus 1 fruits, and you've taken 1 item of fruit out, so now there are 3x items of fruit. How many oranges are there? The oranges haven't changed, there are 2x. So it's 2x, the probability of orange, second time, is 2x of 3x. So to get them both, you times them. So therefore, x over 3x plus 1 multiplied by 2x over 3x must equal 5/23. Now, just before you launch ahead and start multiplying, etc., there's an x timesing on top, x timesing on bottom here. They would cancel. So then you could just do 2 times x and 3 times this. So you would get 2x over 3 times this would be 9x plus 3 must equal 5/23. Okay, multiply both sides by 23. Okay, and then multiply both sides by 9x plus 3. That would get you, on this side, 23 times 2x, which is 46x, would be 5 times this, which would be 45x plus 15. Take away 45x from both sides, and you would get x is equal to 15. Does that make sense from what we were talking about before? Let's just double check we've got the right answer. If we had x apples, we'd have 15 apples, 2x oranges is 30 oranges, and 1 banana. In total, we therefore have 46 items of fruit. And to get an apple followed by an apple would be 15 out of 46, then multiplied by 30 out of 45. And if we did that multiplication, would we get 5/23? Well, I think we would, because we could simplify this fraction down, divided them by 5, so you would get 15/46 multiplied by 6/9, which is 2/3, which is 15/46 times 2/3. The 3's would cancel there, and you get 10/46, which simplifies to 5/23, as you were looking for. It's harder to check it in this case, but that is the final answer. X is equal to 15.